Hey everybody, it's good to see you all again. I'm Paul Yuknovich. I'm one of the product leads on the Azure Dev Platform team. We especially work on things like applications and frameworks. I'm here to talk to you today about Dapr, which is just short for Distributed Application Runtime. And Dapr is really exciting. It's here to help us build microservices. We've been building it with the community actually for the last 2 years, so it's fully open source, free open source. Kendra, to answer your question, 43% of all contributions this month were external. I just was looking at that, so really exciting to be building this one with the community. And today I want to show you what it's like to build applications with Dapr and .NET. Just an awesome experience put together. So just let's talk a little bit about what motivated us with Dapr. The first thing is there's a number of challenges to build microservices applications. There's best practices to get scale, to get resiliency, to get security. And there's really pretty limited tools out there to help us build and test and diagnose these kinds of distributed applications. And for the solutions that are out there, we find that their runtimes are a bit locked in. There's limited language support, limited hosting support. There's limits all over the place. So when we set out to do Dapr, we wanted to release those limits and make sure that Dapr is fully portable, runs everywhere, runs where you want it to, runs with the software you want it to. So I think when you see today, not only will we solve microservices problems like resiliency, but we're going to focus on portability with Dapr. So introducing Dapr. So Dapr, again, is distributed application runtime. And the way I think about it, and this is new copy I'm going to try out just today, Dapr is APIs to build portable and reliable microservices. We want to focus on a few things here. First of all, it is APIs. It's for developers. There literally are RESTful APIs that we call to do tasks, whether it's microservices communication, working with state management, working with secrets, doing pub/sub. So we're going to call those APIs. And the focus of those APIs is A, to give you reliability so that every call you make is resilient. There's retries, there's backoffs, there's those kinds of best practices. They're secure. We'll use encryption, MTLS. And they're going to be portable, right? So you can write against these APIs once, but you can port the same application, the same microservices to all different kinds of environments, and it's going to work well. For you in the .NET community, there's a few customers that you might want to check out kind of their technical case studies. One is Man Group, one is Zeiss. Actually, I would check out all of them, but they use .NET, and I thought that would be really cool for you to know about. Let's talk about Man Group. Man Group was building a consolidated set of APIs over all of their services, and they're distributed on all different kinds of heterogeneous environments, a lot of them really on-prem and edge VMs. And they're able to pull that environment together and get those microservices talking together using Dapr and establish consistency and continuity across the team. Zeiss is also really cool. They're doing some cloud native practices like virtual actors, and they're able to use the programming model to get that reliability and portability for their app. So let's talk a bit more about the features of Dapr. We talked about there's APIs, there's resiliency that's just built in. There's scenarios around microservice communication. So I think about two things, service-to-service calls, and I think about messaging and event-based, which is about using a messaging broker to send messages asynchronously to publish and subscribe. And then when we're doing these scenarios, there's other features within our microservice that matters. Like when you have lots and lots of microservices out there, service discovery is a huge thing that you need. So that's built in. Having secure communication is a huge thing. So MTLS and encryption is built in. And even you'll see that we'll use middlewares that can give us even more enhancements around it. Like let's say we want to use our favorite OSS middlewares like Spiffy, or we want to use open telemetry to get better observability. Those are the kinds of things we'll do. And we have a secret management story also, so you can use Key Vault or Vault or your secure system. All of this really works thanks to a sidecar process. I'd say that's kind of the workhorse of Dapr. So I'm going to show here in this diagram, we're just going to do service-to-service invocation. It's my application calling another service. Here we call it service 1. So my application, instead of calling service 1 directly, where it could be insecure, it could be unreliable, We're going to spin up a sidecar process next to my app, and we're going to spin up a sidecar service next to service 1. They're almost like the twins, the digital twins that go with our application services. But that sidecar is going to expose these microservice APIs, and that sidecar is going to do the heavy lifting to secure things, to make retries happen, to make it more resilient, to do the service discovery. So that's really the magic and kind of the backbone behind Dapr and why it's a little bit different. And we're going to see in a little bit, it's actually easier to adopt Dapr because we have these sidecars. You don't have to rewrite your application, redo your architecture. You can stand up an additional sidecar, and boom, all these APIs are stood up next to your app. Here's another scenario. I think more and more we're seeing high-scale distributed applications, whether it's a web app or a distributed backend system. We're building them using pub/sub messaging so that in a queue-based and a message-based fashion, we can send off work to be done, and then we can have a big pool of services that can horizontally scale out and do the work for us. So pub/sub is a good architecture for that, and we have pub/sub functionality built in. And what I want to call out, as we can see in the diagram, this is also where portability comes in. Dapr lets us bind to or configure our most favorite brokers, right? So like I could use Kafka for open source. I can use Azure Service Bus or Event Hubs. I can use other clouds like Google Cloud's pub/sub. So we have a lot of flexibility, and the same code can simply be configured and rebound to all these different environments, whether it's cloud, edge, on-prem, local machine, et cetera. And there's way more to talk about than I have time for in this half hour. These are some of the scenarios that you can also do. I think input and output bindings for events is something that we don't have time to cover, but it's there. Same thing with state management. Same thing with virtual actors, which are great for having thousands and thousands of objects that are communicating like microservices. So let's drill in just a second about sidecars, and then I'm going to pop into a demo. So like I said, the sidecar is kind of the hidden star of Dapr. We want our service to call a sidecar, and it's just a process. It's not a container. It's not another service. It's just a process. We'll talk to it through our choice of HTTP or gRPC, and we'll get these RESTful endpoints. So I know that on localhost port 3500, there's a new set of APIs that will live there. I can do invoke to do service discovery and just call another service called cart and call an action off of it called new order. I can call the state API, and I can talk to my favorite backend. Could be Redis, could be Cosmos DB, could be blob storage, SQL, all kinds of options. We have a publish API for pub/sub. We have secrets for vaults and key vaults. And you're starting to see like Dapr is providing that set of APIs off of the sidecar. And like I mentioned previously, those APIs that you delegate to are going to do that heavy lifting with the microservices communication and all the best practices. I also mentioned that this is incrementally adoptable. So yes, there's new APIs, but a big thing I want to drive home, you don't have to rewrite your .NET apps. So one thing we're really proud of that we did, actually the community contributed a lot of it over the last month, is what we call HTTP or a gRPC proxy. All that really means is you can use your favorite HTTP or gRPC client. You know, in this case, I'm showing .NET's HTTP client factory. I can use that, and just simply as the bold line shows, I'm just going to set a header, Dapr app ID, and I'm going to pass in, the name of the service. That's all I needed to do to say, hey, I'm making a Dapr call through the sidecar, and you can go ahead and do service discovery on that Dapr app ID. That's really it. And also, I reset my environment variable for my base URL from whatever IP address or domain name I was using. Now I'm using localhost 3500. That's the address of our sidecar. So it's really that simple, and that's yet another tool we have in our arsenal to make this thing really portable between all the different environments. Okay, so enough slides. Let's pop over to a demo. So what I have here, what I think I have here, here we go. We're going to show really quick how we stand up an application with microservices. This one's going to be a little bit more interesting than Hello World. We're going to have a Twitter sentiment analyzer. Seems very good for a day like today. I'm going to have a handler that's kind of like my API gateway. It's listening to Twitter tweets, and it's treating them like events. When those come in, we're going to send some work out. We're going to call our sentiment processor, and our sentiment processor is going to use an Azure AI cognitive service. It's going to score the tweet. It's going to pass that back. And then this microservice is going to do a couple more pieces of work. It's going to go ahead and persist the tweet into our favorite state store. So I'm calling state in the tweet store. And I'm going to publish a message, pub sub style, so that downstream clients, like this nice little HTML viewer app, can subscribe and do some cool stuff with that data. So you can see I have a small distributed system. It's both event-driven and it's using asynchronous HTTP calls. And Dapr is going to take care of doing that for me. So I'm going to go to my code, and I can see this is really nice. In my provider app, we're using .NET 6, and I've got a really nice experience in program CS where I'm going to handle an event just by mapping the post for the tweet event. And so Dapr is giving me a nice integration with ASP.NET and those middlewares. I'm just going to handle that tweet. And then I'm going to go through that asynchronous workflow that we just saw in the diagram. I'm going to score the tweet. I'm going to save the state to any state store that's configured. And I'm going to publish the event, just like that. And if I look at my configuration, these APIs, that's the only code I wrote, but they're backed by these configuration files. So I can see that Twitter is signed up with my Twitter user account and my keys and secrets and access tokens and things like that. Notice that I don't have any secrets posted in source code. That's a totally horrible idea. Instead, I'm using the best practice of a secret store, and that's going to be backed by my local machine here or by Key Vault when I put it in the cloud. And same thing with State Store. I have a whole bunch of options. On my local machine, Dapr will actually set up a Redis container for you just for development purposes. So I'm more than happy to bind to that Redis container. When I deploy it to the cloud, I can use a PostgreSQL, I can use Azure Redis, let's say, I can use Cosmos DB, even blob storage. So I've got all these different options, and I'm just going to literally have a different config, and I'm going to bind mount the application on that config, and that's it. So that's a good way to kind of think about the portability of Dapr. So let's go and run this thing. The way you would run an app with Dapr is from the command line. We have a CLI. You could say Dapr run, pass in a few parameters, like the name of your service. And ultimately, for .NET, we're going to do a .NET run on our project. So it's like Dapr run, arguments, .NET run. Pretty straightforward. So we're just adding that extra step of Dapr run to start the sidecar. That gets a bit tedious times each microservice that you have, and we've recognized that. So we have another open source project that I'm going to call on called Ty, which also was born out of the .NET team, which I'm super proud of. I can just say Ty run with my Ty definition, and the app's going to start all my microservices. It's going to make sure they're healthy, and then I get this really cool dashboard. So I can see in the dashboard my 3 microservices have been stood up. We will check the health, and knock on wood, everything looks good. There's no reboots, no restarts, no recycling. And then I can start looking at the log tail, and I can see, wow, it's actually like scoring tweets from Microsoft, getting the sentiment, and it's sending that data around between the microservices. So if I go back to the provider, oops. It's fun in this resolution. I can see that we're scoring tweet after tweet after tweet in an event-driven style. And then let's actually check out the application. If I remember, it's on port 5000. Here we go. And just a second, this is the app that's, looks like I have a little bug. It looks like the sentiment is awfully negative, even though that was a super positive thing. So I still have work to do in my microservice, but the machinery of setting up the microservices is handled for me with Dapr. And now, as it looks like, I need to focus on my business logic and my logic to make sure that that's correct. So that's some neat things we can do. We'll pop back over to the slides. And I want to summarize some things that we did. So some of the best practices we saw, by using Dapr and the Dapr sidecars, we enabled a lot of reliability and resiliency best practices. We enable MTLS by default, so all of your microservice communication is secured, authenticated in that style. We enable resilient state practices. So you saw that when I got a tweet event and I did my work, I persisted it off to a Redis cache or off to a Redis database, and I offloaded that state. So even if my microservice goes down or it scales out, the state is durable, and when the service rehydrates, it's going to rehydrate with that durable state. So all of those best practices of statefulness are built in. Then it's been an ongoing process over the last 6 months, but we've been adding and adding and adding all kinds of communication resiliency features. So now we're adding retries, back off, and circuit breakers. That's completely built in. That's no longer work that we have to do. In the case of messaging and PubSub, there's message guarantees. So there's at least one message handling guarantee that's built in. Again, that's another example of best practices. And if I have time, maybe I can show you observability. We also saw some of the portability things that we do. You know, I think about portability in a lot of dimensions. Like if you think of the dev lifecycle, you go from local to dev test to staging to prod. Maybe you have a pre-prod in between. Maybe you have a fleet of prod around the world. But those all represent different environments that are going to be configured different ways with different services, different choices. Like maybe I'm going to use something inexpensive for dev test, something more expensive for prod. The cool thing is, like we showed, you write against the APIs once, and through config, you will bind to the infrastructure you want. And you can bind to proprietary cloud infrastructure, or you can bind to your favorite OSS infrastructure. Like we showed, we're using Redis. I could use RabbitMQ. I could pop between these different technologies. And if you carry that a little bit further, Dapr's got pretty wide support. You can write in many of the most popular languages. Like here we're showing Go, Node, Python, .NET, Java, PHP, the list goes on. You know, and as a .NET developer, you might find like, yeah, I'm writing some functions in Python and I'm supporting some other languages. So the cool thing is your team, your org, can bring all these languages together and they can kind of communicate in a standard way using Dapr. And that's true for all of the building block APIs that we have. And then there's a number of hosting infrastructures that, as a project, we've been working on. So Azure, Google Cloud, AWS, Alibaba, and Alibaba is actually one of our maintainers and steering committees. So they have been building their FAS also using Dapr. So there's just really that broad portability. That's the thing we've been focusing on. And then one of the last cool things that enables the portability is just that set of components. We're over 70. I haven't done an exact count like I did the contributions, but I'll count it for you after this. But really there's a whole ton of components, like components in each cloud, your favorite OSS components, and even some of the ones that we've used for decades. We have support, you know, based on community demand for those most common components. And I think that's going to like keep Dapr open and growing to, you know, work with the solutions you have. And I promised, do we still have time, Jeff, for one more demo, you think? Oh, yeah. That's awesome. Kendra, you're okay with that?
Yeah.
Okay, good.
For you? Yes.
Thank you. All right, so we're going to pop back. Let's show, you know, some of the portability. So I mentioned we can just configure things. We can configure features and the APIs will light up. So we'll use our own docs. So these are the docs on observability. And let's turn on observability using Zipkin. That sounds kind of cool. So we're just going to copy this, a little bit of YAML. Does everyone like YAML? There's mixed emotions. So I like YAML. And then we will paste this in and make sure we've got spaces and not indents. Okay. So what we're doing here basically is we're going to set up observability using Zipkin. We're going to stand it up on a local, kind of another sidecar on a local address. And it just so happens that one of the things that the Dapr CLI tool installs, we install Zipkin and we install Redis, so they're kind of there for the developer. Like if I check maybe in another terminal, if I do Docker PS, I can see that Dapr's placement container is up there, but also the Redis and the Zipkin. So anyway, now that I've done that, let's rerun the application. Like, I'm not changing code, I'm not recompiling, none of that good stuff. We're just going to run it again. Boop. And if I've had enough coffee and everything's good, then we're going to see some magic. So we'll pop open the dashboard again, and a thing, again, I always like to do is I look for service health, no restarts, no crazy errors. In fact, I'm seeing tweets pop through. And let's look at the port for Zipkin. Looks like 9411. So let's take a peek at that. Whoop. And this is pretty cool. So just by adding that config, we can see that, that Zipkin for observability was stood up. And I can see that even, this is live stuff, I can see all those events being processed and all the microservices being called. So let's look at a distributed trace. Like, look, we're tracing all the way through. The provider is calling the tweets. You can see the Dapr Sidecar underneath. Even though we called through HTTP, it's going to make its own calls through gRPC because we're going to be even more efficient over the wire. And then you can see a trace all the way through to the viewer. Another thing that's super slick about Zipkin, I love doing this. Oh, we're being camera shy on this one. Well, there's a view that usually, I wonder if I stopped the app. Jeff, did you stop the app?
I did not.
Oh, okay. It's worth a try. Let's try one more time. The cloud way is sort of to try things again. All right. Oh, there we go. So we're back up and running. We just had to turn it off and on again. Okay, and here we go. And so it's a little funky in the Zoom. But I can see in real-time observability with the requests going across the wire from microservice to microservice, and I can inspect each one. So I'm getting that real-time observability. It works here on my local machine. And again, this is portable, so it'll run in any cloud and on the edge, all with my favorite OSS or with my favorite kind of cloud services. So that's something I always like to show. It's a freebie. Just add the config file, and it adds the features. So with that said, it's sad to say we are wrapping up. But in the wrap-up, what I want to show you is some things that you can all try, and I'd really recommend it. So we have a getting started guide, with it, which I think is really helpful. It walks you through, go get the CLI. It sets up the containers. There's some really good quick starts, some really good samples, including the Twitter one. And everything you saw here, I have online for you. So like the Sentiment app, there's a cool store API, which we can push to the new Azure Container App Service. And also, like beyond just kind of trying it out, I'd really encourage you to join the community. I think one of the intangible features of Dapr is there's just an awesome community around it. Literally, just tons of contributors discussing in the Discord, adding issues, adding contributions in GitHub. So it's a really fun place to be, and I hope to see you there. Maybe we have some time for questions.
I think we do have a little bit of time for questions.
Okay.
Absolutely. Thank you so much, Paul. That was awesome.
Thanks, Kendra.
All right, we love seeing Dapr stuff. Okay, which
Absolutely.
one first? First off, are you a darn wizard?
A darn wizard.
You got some love on
Please, thank you.
that. No, but really, how long has Dapr been around for?
Dapr has been, it's over a year and a half. I think its origins is like 2 years. It started out as an incubation. an Azure incubation to help with FAS, functions as a service, and it evolved to where it is now, along with the community. And even up to a week ago, where it was voted, and Dapr was voted into CNCF as an incubations project. So it's like,
We gotta
Very
how
give
far
a
we've
plug.
come.
Yeah,
It's
we've
really cool.
that iterating.
It's
Yeah.
evolved so far in just a short year and a half.
Yes.
That's amazing.
Yes.
Oh my gosh. And the features and throwing Zipkin in there with just, I'm going to copy a YAML file and there it
Let's
goes.
just turn on Zipkin. Let's deploy Zipkin, right?
Unreal.
Cool.
Very cool.
So we got a bunch of folks that were talking about, they were watching the Dapr presentation. I don't think we have any other Dapr questions though for right now.
Do you have any Dapr questions?
I've built a Raspberry Pi tower at home that
Yes.
I've installed Kubernetes on.
Okay.
Does it make sense to put Dapr on there?
Yeah, and that's a super great question. So Dapr runs on a lot of things. It is Kubernetes native, so it can run super well on Kubernetes.
Okay.
There's a Helm chart where you can just deploy it that way. And now, if you want to put on AKS, there's a new extension to put on AKS. But for your home,
Yeah, for the little thing where I'm just learning.
it's perfect for
tinkering.
that.
Okay.
But also, you could put it on a VM. You know, you can just whatever you think, or like you could install it to the metal. So lots of different ways. We'll probably add an apt-get, so you could just apt-get it in the future,
Okay. Yeah, that makes things a lot
if you're cool
easier.
with that.
I mean, you've answered my major things. You already have getting started, and you already told me, what is it, 43% contributions open source?
That's
it's
right.
like an actual interactive repo. You could talk directly to the dev team. I love getting that involvement.
And
Pretty-
that
pretty
CNCF
proud.
is a level of validation that, yes, folks like this and want to continue using it.
Absolutely.
So cool.
Oh, good vibes.
And they're going to continue, like folks are actually building it, which is the really cool part. Like the community is building it together with
yeah.
us and other vendors, right? Like Intel and Alibaba. So
So
Very
good.
cool.
Yeah.
Thank you so much, Paul.
thank you so much. Thanks for
That was
having me. Always a
great.
pleasure.